remember, or don't remember, this is the first time, simple trinomial, 3 terms, are written in the form ax squared plus bx plus c, where the coefficient on the x squared term is always 1. So that's what defines it as a simple trinomial. So in this case, remember that a is always 1. A, B, and C are just numbers. They are coefficients, they represent numbers. So examples, x squared plus 15x plus 36. Or x squared plus 12x plus 32. So again, a simple trinomial, the a value, or the coefficient in front of the x squared, is 1. Now, let's go back to Unit 1, and let's see if we can recognize some patterns. What do you notice before? We have factored form and expanded form, which we're going to call something else, which maybe you've seen. Maybe you remember that that's, oh yeah, standard form. So if we were to FOIL, or distribute, use binomial distribution to each of the terms in that binomial times each of the terms there, x times x is x squared, x times 3 is 3x, 7 times x is 7x, 3x plus 7x is 10x, and 7 times 3 is 21. So we start seeing that, weird, how do those connect? These two forms are actually, and if we put y equals, those are the same shape or the same equation. Those are samesies, just written different ways. Remember, in standard form we have a y-intercept, and in factored form we can use each bracket to find out what x would be to make that bracket equal to 0 for our x-intercepts. So factored form we can get our x-intercepts, expanded form we can get our y-intercept. They're the same. So as we go down and you try to see how do 9 and 20 apply to those two numbers? How do 4 and negative 12 relate to 6 and negative 2? How do 7 and negative 30 relate to negative 3 and 10? So you might notice that the two numbers in the brackets are going to add to the b term, and they're going to multiply to the c term, or to give us the c term and to give us the b term. So using that as a guide, maybe we can figure some of this out. So right now, again, we need two numbers that multiply to 1 and add to 2. So this is, if we think about it, and let me write it down here, I'm going to need two numbers that are going to add to 2. And those same two numbers are going to multiply to 1. And whatever those numbers are, they go in the brackets. So right now, we already know that one of them is 1. If we know that one of them is 1, can we figure out the other one? 1 plus 1 is 2. 1 times 1 is 1. So that goes in there. So let's see if we can follow this pattern and problem solve, deduce what's going on. Two numbers that add to 3, and if one of them is 1, the other one is 2, and 1 times 2 is 2. Okay. We have two numbers that multiply to 6. The numbers are 3 and 2, so they're going to add. 3 and 2 added together is 5. Okay. Now, if we need two numbers that multiply to 5, and one of them is already 5, what times 5 equals 5? 1. 1 times 5 equals 5. 1 plus 5 equals 6. So the coefficient in the B spot, or the coefficient in front of x, would be 6. Okay? So again, maybe the reverse operation. So how do we use this? Well, we're going to use that information to actually break these down. We're going to factor them. We're going to turn this trinomial into, we're going to use this trinomial, we're going to turn it into a binomial, x plus or minus some number times x plus or minus some number. So we got to look at what we know. We need to find two numbers that multiply to 36 and that add to 15. Instead of writing all that, I'm going to write, we need two numbers that multiply to 36 and that add to 15. They have to be the same numbers. And so those are going to be what goes there or what goes here and how we work it out. If we're not sure where to start, let's start with everything that multiplies to 36. So we might take our calculator and we might say 36 divided by 1 is 36. We might say 36 divided by 2 gives us 18. 36 divided by 3 gives us 12. 36 divided by 4 gives us 9. 36 divided by 5 gives us, 7.2. Well, we want solid numbers. We're not even going to look at that one. 36 divided by 6 gives us 6. And then if we kept going, 7, we wouldn't get anything nice. 8, we wouldn't get anything nice. 9, we've already got 9. So we found a turning point. We don't have to go any further. So those are all the multiples of 36, or all the things that multiply to 36. Now we're going to look at which combination adds to 15. 1 plus 36 is 37. That's no good. 2 plus 18 is 20. Still too much. 3 plus 12 is 15. So we have a positive 3 times a positive 12 gives us 36. That same positive 3 plus 12 gives us 15. There is our winner. So positive 3 and positive 12. If I can do that in my head, I can identify. This is just the thing that helps me out. So what happens? Basically, that 15x disappears. We end up having our final answer, x in one bracket, x in the other bracket, and what's going to go in the brackets with them are these magic numbers. We're going to have a positive 3 in one bracket and a positive 12 in the other bracket. And so what we found, those magic numbers, when that a value is 1, that 15 is going to break up to 3 and 12. 3 plus 12 is 15, and 3 times 12 is 36. So we're doing the opposite, we're basically doing the opposite of FOIL. So now we're trying to figure out the two numbers, that would be the O and the I, add together to give us 15, and the two last would multiply to give us 36. So there we go. Now from that, we could really graph that. From standard form, we know the y-intercept of 36. From here, factored form, we would know our x-intercepts. And our x-intercepts here would be negative 3. Again, what would x have to be to make this bracket equal to 0? Negative 3. And what would x have to be to make that bracket equal to 0? Negative 12. And so we could, at that point, draw our curve, but we just don't know how deep our vertex is. To find that, we would do something and we'd split this in half. We'd find the midpoint of negative 3 and negative 12, which means we add them together, divide them by 2. Negative 15 divided by 2 is negative 7.5. So we know that this value is negative 7.5, and we just don't know how high or how low the y value is, but we could sub in x is 7.5, negative 7.5 in here to solve. And then we'd have our parabola. Nice gentle curve and opening up. And that's how we would apply it. So let's flip the page. Let's do a few more of these together. This is a fundamental skill that we need to master. Practice, practice, practice.